Hi all, this is Aman and today we are going to uncover one of the most exciting things that came out this year, the AGUI protocol, also called the Agent User Interaction Protocol. But before we talk a lot of theory, I want to show you what this thing can actually do because once we see it through our eyes, the entire working, the whole idea will click in together. So this is a sample analytics dashboard. So on this graph, we can track sales, revenue, users, orders over time. We also have the data splitted by categories like electronics, clothing, food, and by regions like north, south, east, and west. Normally, you would click a bunch of filters and buttons here to see the desired view or filtered graph. Instead, what we will do here is we will let the agent control the dashboard using the natural language queries. So first, we will filter the chart by time, category, and region. So I'll just try to use this prompt. The prompt says that show me the revenue and sales for electronics in the North region from May 2024. And I'll just hit the query. Now the request will get processed and see what just happened over here. The chart updated the date range from May 2024. Category changes to electronics and region switched to North. The matrices on the graph shows revenue versus sales and the data points is adjusted over here with a new filter. All of this happens automatically, no manual clicks. The agent tells the UI what to do over here. Now, let's see another magic. So I'll just change the prompt and now I'll ask to change the comparison matrices. So the prompt says that compare user versus order for the same period. And see the magic. The chart keeps the same date range and filter, but now the line changes from revenue and sales to users and order. So the agent is not just answering in text, it is actually deciding which matrices this chart should show. We can also change the chart type as well. So let me just try that. So the prompt says that switch this view to a bar chart and see the magic. The visualization flips from a line chart to a bar chart, but the filters and the matrices still says the same. This is still the same dashboard. The only thing changing is what the agent is asking the UI to do. So here the agent turns those requests into actions on the dashboard, and AGUI is the protocol that carries those actions between the agent and the front end. So from here, we can now break down what AGUI is and how this flow is wired under the hood. Now that you have seen the entire experience, let's break down how we get there. Here is the agenda for the video. So the first, we will start with the basic why this protocol exists and the problem it solves. Then we will look at the full flow from user to the front end through AGUI into the agent. And then next, we will see how AGUI fits directly into the Microsoft's ecosystem via Microsoft Agent Framework. Then we will clear up a few misconceptions so purpose of AGUI becomes crystal clear to you all guys. And finally, we will talk about where AGUI really makes sense in real world applications. So let's get started. AGUI, Agent User Interaction, is a protocol similar to A2A or MCP that connects our agent to real front-end applications. Think of it like a remote control for your app that agent can use it safely. It sends small events back and forth like tiny instructions. With those events, the agent can update the screen, change filters or views. It can call tools or ask the user for something using a human in the review kind of context. So instead of hacking together APIs and callbacks, AGUI gives both the agent and the app a common control system so they always understand each other's language. So let's try to connect it to the demo we just saw. In the demo, the query that we asked, that simple sentence, had to travel through multiple layers before the chart got updated. This is breakdown of exactly how that flow works. The user starts with a natural language query and request. Now, front end, the UI receives the request and simply forward it to the backend. It doesn't decide anything yet. Now AGUI steps in as the messenger. It carries the request from front end to the agent using structured events. Now comes the agent. The agent interprets the request. It pulls shipment data, figures out which deliveries are delays, and identifies the one with the top risks. It then decides what needs to change on the screen. Then AGUI brings those instructions back, not just the final answer, but also UI actions like filters, highlights, sorting, or view changes. Then it sends to the front end, and in the front end, the UI executes those instructions. It updates the dashboard, highlights the risk statements, and shows the final result. Now, finally, the user sees the updated dashboard instantly without touching any filters. So, the smooth experience you saw in the demo wasn't just the magic, it was this loop: user, front end, AGUI, agent, back to the front end, and all in working in the one sync. Next, let's look at how this AGUI architecture work in a real world. So this is the real shape of AGUI in an application. On the front end, you have two pieces: the application that renders the UI and the AGUI client that handles all communication. Here, the app never talks directly to the agent, everything goes through the AGUI client. On the back end, you can have one agent or many, and they can be fast APIs, they can be Microsoft's agent framework, it can be LangGraph as well. Anything that can emit AGUI events, we can have it in the backend. We can also have secure proxies that sits in the middle when you need routing, permission checks, or to pick which agent should handle a request. We can have that secure proxies as well. All the arrow here represent the AGUI protocol. It's the standard language that connects the front end to the agent and keep the whole system in the sync. So this is the core architecture behind AGUI, a simple event-driven bridge between the front end and our agents, no matter how many you have or what kind of framework they run on. Now, let's look at how this actually comes to life inside Microsoft's agent framework. So this is the quick glance of the whole entire code base looks like. So this repo has both the side in one place. The thing that you see under SRC is the Next.js implementation, and the thing that you see under the agent is the fast API backed with Microsoft Agent Framework implemented. So I'll put the full repo link in the description so you can clone it, explore it later instead of pausing the video. So uh, the things entry point for the Next.js is layout.tsx file. So here we wrap the whole entire app under the Copilot kit. So what it does is it's the AGUI client that will emit all the events to our front-end application. And here we specify the runtime URL that points to our API route that we will see in a second. Then we have the agent that tells the client which backend agent you need to talk to. So from this point on, every AGUI event between the UI and the agent flows through this wrapper. Now coming to the API implementation at the front end. So over here we have this Copilot kit implemented API. So this is basically the bridge between the Next.js client and the fast API backend. So what this does is Copilot runtime manages agent for the front end. So over here we register a single agent called my agent. That agent is reached through an HTTP agent that talks AGUI to our backend server, which is currently locally running on port 8000. Then we expose a post handler with Copilot runtime Next.js app router endpoint. So the entire flow will look like this. Copilot in the layout hits the API. This runtime calls the fast API AGUI endpoint. Next, we have this page.tsx implementation where all our front-end logic lives. Here, a few things to notice is we have rendered this Copilot sidebar, which is ready-made prompt-like structure where we get the different prompts that we can try it out, like set the theme color, fill the form, filter the chart for certain matrices and region. So this is just a nice cell around the agent that we can implement, and then we have this sad state within the agent. So we call use co-agent with agent state that keeps a proverb list in sync between the UI and the agent using the AGUI sad state. Front-end actions, we register several copilot actions over here. We can call it as a hook. So set theme color, fill and submit form that fills and optionally submit the contact form as well. Filter chart is the important one for the analytics demo we just saw. It let the agent change the chart type, matrices, and filters that we show, including the date range, category, and the region. So these actions are the only levers the agent has on the front end. There is no DOM hacking, just type control actions. So now coming to this chart.tsx file. So this is basically the entire chart implementation that we have, that we saw on the dashboard. it generates the dummy data with sales, revenue, users, and orders, and then it applies filters on that. The filters that we get directly from the agent, it directly calls these functions and apply the filter over there. So we can see the filtered dashboard in live when the agent responses to the UI. Now coming to the backend implementation. So over here in the agent file, we have Microsoft Agent Framework implemented on the backend, uh, and we define the state schema for the proverb so that framework knows about sad states, and then we declare the tools using this AI function. Currently over here, like we have this update proverbs, get weather, and go to moon functions implemented over here. Then in the create agent, we build a chat agent with a big instruction block that tells the LLM how to keep the proverb list consistent, and when to call the go to moon for the human in the loop, and when to call the actions like fill and submit the form, when to call the filtered chat action on the front end, with different parameters. So we have this instruction defined over here, and then finally we wrap this in agent framework so that it speaks the AGUI event format. And finally, this entire Microsoft Agent Framework, AGUI endpoint, and Fast API, all those things clubs in the main.py file where we wire the agent into the Fast API, and it chooses between the Azure, OpenAI, and OpenAI based on the environment variable that we set. And then we create a Fast API app and then call it over here in the root with the single line that exposes an AGUI compatible endpoint with root path. So the full call chain looks like this. So we have this Nexus Copilot Kit API that calls the Fast API via HTTP agent that is implemented in Microsoft's agent framework back over AGUI to the front end. So that's the full setup connected end to end through AGUI. So why do we care about this AGUI and all this event stuff? So this protocol is what makes the app feel like a co-pilot, not just a text box. Instead of user ask and model replies, the agent can like update the screen, it can call the tool and keep track of what is going on in the background. All of this happens through a small set of standard events, roughly around 16 of them, and they cover most things a real app needs. So let me show you in the list in the doc itself. So first, like we have this life cycle event. This says that when the run started, which step started, which got finished, or if any error occur between the agent execution, and if agent is not able to resolve, this is how the UI knows when to show spinner, when to stop, and when something broke. Now the next we have is the text message events. This stream the answer token by token when the message starts, each content chunk, and when message ends. This is what makes the assistant feel live instead of like waiting us for one big blob. Then we have this tool call event. This covers the tool call start, argument streaming, and tool calls end, and the final result. This is how the UI can show that I'm calling this segment API, or I'm fetching the data from the web, and here is the result. And then next we have this state events, snapshot and deltas that keep sad state in sync, like our proverb list or a chat filter. There are more like activities and custom events, but you can see the full table here in the official documentation. So before we wrap up, let me clear a few misunderstandings I have seen many places when people first hear about AGUI. First of all, AGUI is not a UI library. It doesn't give you buttons or components. It is only the protocol for how the app and the agent talks. Next, it doesn't replace your APIs. Your backend still works the same. AGUI simply sits on top and adds structure, streaming, and events. Then it doesn't lock you into any one framework. As long as an agent framework can emit AGUI compatible events, it works really well. Like Microsoft's agent framework, LangGraph, or any custom agent, all can speak AGUI. Also, AGUI is a transport agnostic. It doesn't force you to use SSC or WebSockets. Use whatever you want. AGUI just defines the event, not how you send it. And last, it's not only for chat. This is the biggest one. AGUI is about actions, tools, UI updates, workflows, anything that requires the agent to collaborate with your application. Now, when should you actually use the AGUI? Use it when our app needs an AI agent that does more than the chat. If the agent needs to trigger UI changes, update charts, fill forms, or walk the user through a workflow, AGUI is the right fit for you. Use it when you want smooth real-time streaming instead of slow request response cycles. AGUI's event model makes your UI feel alive, and believe me, users love to stick over there. So, just to wrap it up, AGUI is not a UI library, it's not a replacement for your APIs, and it's not tied to any of the framework. It is simply a clean, consistent protocol that lets agent talk to your app in a powerful way. And everything that I showed today, the full repo, documentation, links, and extra resources is all in the description. Feel free to explore, clone the project, and build your own AGUI experience.